All right, well, we got a lot of people here, so let's get started. As just a friendly Zoom, hopefully you guys are experienced in Zoom, but if not, I would recommend pinning my little square. So you could push the 3 dots and then pin, and that makes it so it doesn't jump back and forth if someone else is talking and you lose my screen and what I'm doing. So I recommend pinning my little square. And then I am going to ask everyone to mute during class, but I don't want that in any way to stop from shouting out and asking me a question, because I really do depend on your feedback. And that's one of the hard things about teaching on Zoom, as some of you guys know. When I switch to PowerPoint or to my chart, I can't see you guys. So I'm just listening. And if you guys are on mute, I'm listening to nothing. So please shout out with any questions or anything. But since we do have 27 people in the class, that background noise can add up and get pretty distracting. So I might mute you during class, but please don't take offense to that. We're just gonna try to get through this and this new way of learning. So bear with me on that. As for the class, so we are 6:30 to 9:30 on Wednesday nights. I will log on at 5:30. So the Zoom meeting will be the same link every time. I log on at 5:30. So if you guys have any questions or you want to go over homework or anything, I'm always available for that. And feel free to email, text, call, whatever you're comfortable with, anytime during the week if a question comes up. And beyond this class, if you guys have other questions at all, I'm always available. For the class, hopefully everyone got mailed a packet of worksheets, and I do post all of the worksheets on the Google Classroom. If you don't have a Google account, you can't get to the Google Classroom. So maybe create a Google account just for this class so you can have access to it. If you're really struggling with it, I can email you an attachment. But please let me know if you guys have any questions with that. Actually, I am going to bring it up real quick. So hopefully you guys can see can you guys see my Google Classroom screen?
Oh, yes.
Yeah, okay. So at the top, I kind of have just some links to kind of reference material we're going to touch base on that didn't really fit into my other topics. But my other subject are the PowerPoints. So these are all the PowerPoints for each week. And I will be obviously showing you the PowerPoints during class and recording the videos. So you guys can go back to see what I talked about, as well as looking at the PowerPoints if you want to see that picture again or something. And then you have all of the assignments. So on the assignments, you have the actual assignment and then the answers to the assignment. So none of this is graded, right? We're all just trying to further our knowledge of navigation. And so it's not a test or anything, you know, we have this final at the end, but it's not, you know, a final that you need to be stressing over. We're just trying to, you know, test our knowledge. So I'm not just talking and you guys are forgetting everything I'm saying. So, so we have the worksheets and the answers. Hopefully you have a hard copy of the worksheets for each assignment. And then you do have to push view more. So this gets confusing sometimes. But since there's so many assignments, you do have to view more. And then at the bottom, there's video tutorials for each assignment. So this is me doing each assignment on a video tutorial. So check that out as well if you get caught up on a question. And then I do have class notes for weeks 1 and 2. The other weeks, we don't really need the class notes because I kind of put it in the PowerPoint. So that's why I only have weeks 1 and 2 on there. But excuse me. That is our Google Classroom. Let me know if you guys aren't able to get it or you want it in a different format or something. I can be flexible with that. So we have Zoom and the Google Classroom. As for the class, I'll be doing PowerPoints on Zoom. And then I also have, let's see here, let me share screen. I also have a camera that I will be doing the chart work on so we could see it in class. And this also helps when you pin the video to try to make my screen as big as possible so you could see what I'm doing on the chart. And then I use the whiteboard as well a lot. So that's just to give you guys a feel of what to expect for this class. The first 2 weeks are a lot of me talking at you, a lot of lecture, a lot of information. Gosh. And then the weeks after that, we kind of go into the first hour is lecture of a new topic, and then we go into the homework assignments and do them together on the chart so that you really won't have homework for this class. We try to do it as most as we can in class. The more people we have in class, kind of the slower it goes sometimes. So with this amount of people, we might not get through all of the homework assignments together as a class, but like I said, there's resources available, and I am always available as well. So any questions on class so far on what to expect? Are you guys feel prepared for what we're doing?
Agree. This is Inno. I have a question. Should I expect to get hard copy of the charts in my mail?
You definitely do need a hard copy of the charts for the class, but you needed to order them through OCC. And I think, I'm actually not positive if they would mail them to you or you pick them up at OCC.
Okay, so I just should pick up in the school.
Yes, yes.
Okay.
Yes. They have
no problem.
All the charts at the school.
Mm-hmm.
All right, well, to start things off, I know we have a lot of people here, but to start things off, I like to just do a little introduction and see where you guys are at, what you want to get out of this class, what kind of navigating or sailing or powerboating experiences you've had. And yeah, so I'm gonna go first, and then it's a little weird on Zoom, so I'm just gonna call on you to introduce yourself to the class. Sorry. My name is Bree Bennett, and I have my unlimited captain's license. I went to the California Maritime Academy in 2005 and have been sailing all over since about 2 years ago. I stopped sailing and started teaching, and I'm really enjoying it. But I worked on oceanographic research vessels. Those were my favorite. I went all over the world, Atlantic, Pacific, everywhere, on research vessels. I also worked on oil rigs. I've worked on container ships. And then I went back to the academy as an instructor and worked on the training ship with cadets a little while as well. So I have navigated all around. I've worked as, third mate, second mate, chief mate. and I've really enjoyed it, and I like teaching you guys. So with that caveat, my experience and my background is all in the commercial industry. I don't have experience in the recreational boating industry, which I know is what you guys are coming from. So I don't know exactly what it's like on a power boat or sailboat, but the basics of navigation can be found in all of it. And so sometimes I might ask you guys as a group, like, oh, what is it like on your sailboats, or your experiences. Your wheelhouse isn't quite set up as the wheelhouses on board the large commercial vessels that I have experience on. So throwing out that caveat there, just so you know where I'm coming from. But yeah, that is me. And yeah, let's get started introducing ourselves. Billy, can you go first? All right. Well, we got a lot of people in this class. I'm excited about it, and a pretty good mix of sail and power. So that's really going to be fun too. So we got sailing and power in here. So I'm liking that. It's going to be good. Well, we're going to just dive right into it if you guys are okay with that. You've been sitting here for a minute. So let's bring up my PowerPoint. Okay. Can you guys see my PowerPoint?
Yep. Yes.
Okay. Okay, great.
Yep.
Okay. So I can't see you guys, but like I said, try to stay on mute so we don't get all the background noise, but definitely shout out anytime you have a question or anything like that. I'll try to keep this chat up. Okay, let's see. Let's dive into it. So this week, we're going to mainly be talking about charts and pubs and kind of what's on the chart. If you've never seen a chart, hopefully you can have a chart in front of you and be looking around on it. And we're going to kind of do this familiarization and what all these new terms kind of mean with that. And then we'll dive in a little bit to the nav pubs. Most of it is online now, but we'll still use some of those nav pubs. Okay, so let's click. This is the 18746. That is the other chart, one of the two charts that is required for this class that we are going to be doing our navigation exercises on. As you can see, it's the San Pedro Channel. We have Newport, Dana Point, and then up to the Long Beach, LA Harbor. And you have the two large traffic lanes, but we'll be going over that later, and Catalina. So there's so much information on this chart. Again, it's different than if you were to bring out a road map you got from AAA or something. So we want to be able to see the information on this chart and process it. So we're going to take it step by step so we can see, oh, the chart is really showing me a ton of information, not just squiggly lines and numbers everywhere, but what that information actually means. So that's what we're going to be talking about. The other chart I don't have a picture of right now on this PowerPoint, but it is a training chart, and that is on the East Coast. It's going to be Buzzards Bay, Massachusetts, Rhode Island, Martha's Vineyard, that area. I know a few of you are taking that 100-ton class. If you're taking anything with the U.S. Coast Guard, license-wise, they test everything on the East Coast, and it is centered around the East Coast, large vessels, and you use pubs from like 1957 or something like that. So it is all old stuff. So when we look at the training chart versus the new San Pedro channel chart local to us, you're going to see some big differences. There's been some modernization along the way. So that training chart is pretty old. Definitely don't use it for navigation, but you're going to see some of those differences there. But as those 100-tonners, it's very important for you to be familiar with the charts that you're going to be tested on. And this training chart actually, the 1210TR is not one that you're going to be tested on, but that's the way it goes. There's 3 other ones. Okay. So the first thing we're going to talk about is projections and how we get part of a round globe to a flat piece of paper, a large flat piece of paper. There's going to be some distortion along the way. I remember back in elementary school, one of my teachers had us do this experiment of trying to get an orange peel to lay flat, and everybody had their own way of trying to get it to lay flat. That's pretty much what projection is. It's all these different ways of how to get a sphere to something flat. So something is going to be distorted along the way. So it's good to know what type of projection you're looking at so you can have an idea of what kind of distortions may or may not be there. So our first and most likely every chart that you are going to be working on is a Mercator projection. And that is if you were to wrap a piece of paper around the sphere or the globe and kind of project it outwards. So it's a wrapped piece of paper around a globe projected outwards. So your distortion that you're going to get is at the poles or at the ends of where that paper is kind of touching, is wrapping around the sphere. So that's where we get, you know, really large Greenland, really large Antarctica, and distortion down there. But for the most part, the mid-latitudes is where most of the sailing happens, and so we use Mercator projection most of the time. Here's an example. We have a very large Greenland, and then they cut most of Antarctica off, but this is that Mercator projection. The other thing to note about Mercator projection is that you can see our lines, kind of this grid on the chart, are perpendicular to one another. So they have those right angles, and it makes it a whole lot easier as a navigator to navigate on something that has these straight right angles. So all of our longitude lines, which we're going to go over in a minute, and our latitude lines are parallel to one another and then perpendicular to one another, which makes it much easier as a navigator. The other type that you might see, well, there's many other types, but another popular one that you might see is a mnemonic chart. Mnemonic charts are, instead of wrapping around a globe, it's going to be tangent to just one point on this circle. So it's just tangent to one single point instead of having that kind of wrap around the curve of the sphere. And so that's what a mnemonic chart is. The mnemonic charts are typically used in those polar regions, in the, you know, maybe not Gulf of Alaska, Bering Sea, or up near Greenland or Iceland. And those polar regions where your longitude lines are a lot closer together. Excuse me. So that's where you're going to see some of those, but most likely you're not going to see them. This is an example of a mnemonic chart. So you have, different than the other one, the latitude lines are all curved, and those longitude lines, that grid that we're seeing, are not parallel to each other or perpendicular to give us those 90-degree angles. So for your day-to-day navigation, it's a lot harder to use this mnemonic chart. However, for long distance voyage planning, the mnemonic chart is great. And I will get into why that is. But you can see the differences here where you have these curved lines versus the Mercator chart are those straight 90-degree angles. So the big thing about a mnemonic chart is going to be how we create these distances. So if we were going from, okay, so over here is New York. If we're going from New York over to Europe somewhere, on the mnemonic chart, if you draw a straight line there, just using a straight line, that is going to be the closest, the shortest possible route. So when you look on a globe, bear with me here, and you want to go from point A to point B on a string, it is the shortest possible distance. But if you were to go on a single parallel, because of the sphere, it's going to be a lot longer. And that is why you see an example of the airlines, the planes. If you're looking at the back, I know most of us haven't been on a plane in a long time, but if you look in the back of the magazine and see the plane route, they go very high altitudes and then to their destination. And that's because they're saving miles, they're saving fuel, because the Earth is smaller at the poles than it is to stay on the equator. So you're cutting distances out when you're, they call it the Great Circle route. But when you do this arced path. So when we look at the mnemonic chart, a straight line, if I want to go from point A to point B, I draw the straight line, excuse me, and that will tell me the shortest possible distance. Where, hold on, where on a Mercator chart, that straight line is going to be curved, but it's easier to navigate on a Mercator chart. So you kind of had these pros and cons, or what you're doing and what is the best chart to use for that. So your long distance voyage planning, mnemonic charts are great. Your Mercator is your daily navigation. That's the easiest way to navigate. How you transfer your information, you draw your straight line. So this one's from Japan to San Francisco. And then you could just plot a waypoint on each latitude and then transfer those waypoints to a Mercator chart, and you get the shortest possible route. So this is typically what your commercial vessels do. And this is what they call a Great Circle route. So that Great Circle is kind of that shortest possible distance is a Great Circle. So on a Mercator projection, that Great Circle route is curved. It's curved towards the pole. Where a rhumb line, that's just a new vocab word for us here, rhumb line is going to be straight. So if I want to go from Norfolk to wherever this is, English Channel, without changing course. I don't want to change course. I don't care how long it takes me or what the fuel costs are. I just want to set a course and go directly there. That's going to be a rhumb line. But of course, you have the curve of the Earth on that one, so it will be a little bit longer. As you can see, what is about 100 miles difference. So if you don't really care, maybe it's just easier for you to do a rhumb line. But as sometimes your smart electronics will have a little GC or RL next to a route. If you say, oh, I want to go from Norfolk to England, they'll give you the distance and the course, but it will say GC or RL, and you want to know what that means. Is this a great circle course that I'm going to be changing course constantly? Also going into higher latitudes, maybe you know, some ice or other things can be involved in that. Worse weather. A lot of commercial vessels will do rum line to the south to avoid the weather. But anyways, so that's the Mercator projection, the one that we typically use. On a mnemonic chart, it's opposite. So I'm going to go back to this picture. So both pictures of the United States. This top left one, is this a Mercator or mnemonic projection? Anybody? Shout it out.
Mnemonic.
Mnemonic, because it has this curved line, right? It gives us that curve. That's along the latitude. Where this bottom one is going to be your Mercator, where those latitude lines and longitude lines are all perpendicular to each other. So there is a little bit of distortion in one way or the other. And it's just good to be aware of what you're looking at and what kind of distortion may or may not be there. So that is projections. Does anybody have any questions on projections? That kind of makes sense.
Hey, Bri, I had a quick question.
Yeah.
On that mnemonic chart slide that you had, so what was the point of tangent? Was it the one that's like right there in the middle, that circle? Yes. And the two? Okay.
This is the point of tangent, where when you're measuring something, you go back to the point of tangent to measure. Where on a Mercator projection, you could measure your angles from any longitude line. Where the mnemonic chart, you have to bring things back to the point of tangent to measure distance and direction, which is that point right there. Cool. Okay, so let's talk about latitude. So we're going to talk about latitude and longitude. These are our two data points that that we use to figure out or communicate to another vessel or to somebody about where we are on the Earth and how it's divided up. So there's latitude and longitude everywhere, right? It's not just on the ocean. But what is latitude and what is longitude? So our latitude is if you were to, you know, let's see, cut the world in half on the equator. So the equator is going, if I draw a line from the North Pole to the South Pole, the equator is going to be perpendicular to it. And it cuts the world, the largest possible point, right? That's the equator. And then it parallels the equator from 0. Our 0 is going to be the equator line, and the pole is going to be 90. So we have 0 at the equator, and then as your angles or as your complete parallels go through the sphere, it gets to 90 at the North Pole and 90 at the South Pole. So if you're looking at measuring this angle, I want us to look at this picture right here for latitude. So we have the equator, and then if I get 15 degrees north, so that is going to be kind of from the center of the Earth, 15 degrees north, and then it's as if a piece of paper sliced the world in parallel to the equator at that 15 degrees. So that 15 degrees north line goes all the way around the whole Earth. And then you can see that 45-degree line. That's going to be a 45-degree angle from the equator, 45 degrees north. And that 45-degree line goes all the way around the equator. So that's why in latitude, our ranges go from 0 at the equator to 90 at the poles. We can't go any higher than 90 because 90 is the poles. That's our max. It goes from 0 to 90 degrees for north or south. Now for longitude lines are not parallel to one another. They all meet at an access point, and that access is the north and south pole. So every single longitude line cuts the world in half equally. So as you can see, we have half the world on this side, half the world on this side for each longitude line, where our parallels or latitudes get smaller and smaller as they go to the top of the earth, right? They get shorter and shorter. But the distance between your latitudes are equal, right? It's 1 degree. They're parallel to one another. The physical distance between them are equal. Excuse me, I went the wrong way. Where your latitude lines, the distance between one latitude line and another latitude line is different at the equator versus the poles. They're very close together because they're all converging at the poles. So that's our longitude lines. Our longitude lines go from, does anyone know the start point for the longitude lines?
Prime meridian?
Prime meridian, yes. So that's our 0. And then we go 180 degrees to the west and 180 degrees to the east. So we start at the prime meridian and then we go east and west 180 degrees until we get to, what is that at that point? That 180 degree line.
The international date line.
International date line, yep. Which our international date line is a little zigzaggy, right? But that 180 degrees, that's where our international date line is. So we have 180 to the 0 to 180 and 0 to 180. So that max number that I could possibly get in longitude is 180. So when we look at these numbers, our latitude is going to be 2 digits because it's 0 to 90. That's our maximum. So our latitude is 2 digits. Our longitude is 3 digits because it can go 0 to 180. If you are, when we navigate on the East Coast, we're going to be in the 70s for longitude. We always have to have a placeholder. So we say 070 for 70 degrees of longitude. And that should be an indicator of what number am I looking at? Is it latitude? Is it longitude? Is it miles? Is it course? Is it distance? We always, it's great. And we should all get in the habit here of labeling things properly. But in case somebody just jotted down a number, it's good to know that your 2-digit degree is going to be your latitude. Your 3-digit degree is going to be your longitude. And then we also want to put an indicator of north or south for latitude, and then east or west for longitude. Hopefully, you know what hemisphere of the world you are in, but it's the habit we want to get into to document, is it north or south or east or west from the equator or from the prime meridian. That's our 0 lines. Now, we typically, and in this class, but most of the time, you're going to see your latitude and longitude in this format at the top here, where you have your degrees, and then it's called minutes. Minutes, in this case, have nothing to do with time. it is just an indication of an arc, of a measurement of an arc. So you have 360 degrees of a circle, and then in that 1 degree is going to be 60 minutes. And in that 60 minutes is going to be 60 seconds. Again, these 60 minutes and 60 seconds have nothing to do with time. It's just the measurement of an arc. So typically we are going to have our, when you put on your GPS, it's going to show you degrees and minutes. So the maximum number you could have on the minute side is 60, because then it becomes another degree. So that is going to kind of change the way we add and subtract things. We're also going to do this with time, and a lot of exercises with time, where we're adding and subtracting time, but we don't have things in that tenths or hundredths, because we're in minutes and seconds and degrees, or time, minutes and hours and days. So that's just a little thing to keep in mind. Sometimes you are going to see your GPS or your position in whole degrees, and those have different symbols, right? We have a number with a decimal place and then a degree. And this is typically like if you drop a pin on Google and ask what the position is, it's going to give it to you in whole degrees. So some units, whatever type of thing that you're using, if it's land-based, it might be giving it to you in whole degrees. So it's good that good to keep in mind both of these numbers, right, past that decimal point, are over 60, or it's impossible to have that number in minutes because it's over 60. But this is what it would be in whole degrees. Also in whole degrees, we have positive and negative numbers. And again, this is typically with your Google or your other programs I've used, where your latitude is going to be positive in the north, negative in the south. Your longitude is positive in the east, negative in the west. I guess that's just the way it is there. And then we're going to see some charts that are very zoomed in or large scale, are going to have degrees, minutes, and seconds. So that's where we get degrees, minutes, and then seconds instead of tenths of a degree. You just get a little bit more detail, and that's going to be our very zoomed in charts. When we look at the 18746, our data point chart is in degrees, minutes, and seconds. So we can take a look at that. Okay. I guess the other thing that I don't have a slide for, I'm looking for the slide, but I'm going to write it because it is important. So for latitude, 1 degree of latitude has 60 minutes. That little tick is what we use for minutes. And with latitude, they're all equally distant. They're parallel. So if 1 degree has 60 minutes, 1 minute is equal to 1 nautical mile. This is the big guy. So that is where we get a nautical mile, and why it's not a statute mile. And what's the difference between a statute mile and a nautical mile? We have 1 minute, so that's 1/60th of a degree of the Earth, so the whole Earth measured, right? 1/60th of a degree is 1 nautical mile. So 1 degree has 60 minutes. 1 minute is equal to 1 nautical mile. And that's on latitude, because the difference between our latitudes doesn't change. So our latitudes, here's the equator, are equally distant, where our longitude, here's the prime meridian, are not equally distant. The distance at the equator is different than the distance at the poles. So we cannot measure distance using longitude. We could only measure distance using latitude. But we're going to go into practice on that. But I just wanted to mention that here before we move on. Does anyone have any questions on latitude and longitude? Okay. Okay, so I mentioned this a little bit earlier, but this is the chartlet, or a smaller picture, kind of zoomed in here, of Dana Point. And on the side of the chart, we can see that it goes from 27 minutes to 28 minutes, right? So that is going to be 1 nautical mile. We have 27 minutes because it has that one single tick, and then we have 28 minutes, and this is 33 degrees. So within that, I like to count kind of the units we have. So they have it divided up from 10, 20, 30, 40, 50, and then another minute. So that would be, you know, divided up into 60ths, and that would make it seconds, where our, I'm going to jump to it here, hold on. Our latitude lines, if we count these little ticks, there's 10 of them. So that's going to be tenths of a minute. So that's where our difference between our degrees, minutes, and tenths of a minute versus back to, I know this is confusing. Here, where there's 60 little ticks between it, and that is degrees, minutes, and seconds. So, but again, in this class and in most things that you are going to be seeing, this is the format of latitude and longitude that you're going to be seeing. Again, this is a measurement from the equator for latitude, from the equator, north or south. And for the longitude, it's from the prime meridian, which goes through England, and then east or west of England, pretty much. Okay. Is everyone okay so far? All right. Before we dive into chart orientation, let's take a little 10-minute break here. We've been sitting and looking at our computer for a while. So let's try to take a little break, and we'll come back at 7:55.
Hey, Bree, I have a question. Can you hear me?
Yeah, go ahead.
So the distance is in between the latitude lines, which is measured on the vertical longitude scale, correct? Because the longitude lines are all equal distance.
Correct.
So I think the confusion would be people are hearing, you know, distance is measured on latitude, but it's actually the distance between the latitude lines, which is measured on the vertical scale, which is actually a longitude line.
Correct.
Yeah. Okay. Otherwise, I've been driving my boats in completely the wrong direction.
I guess we're kind of learning the why behind it. So that way you can remember that the distance between latitudes is what we use for distance and not just the vertical line.
So Bree, do you actually go to the OCC classes at all? Or do you ever go to their campus off PCH?
Yes, I was teaching this class in person before COVID.
Do you still go? I think it's open kind of part-time. I mean, they have shields on the weekends, on Saturday mornings.
Yes, they do have on the water classes, but I think all of their in the classroom classes are online. Is the 100-ton class that's coming up, that's going to be online as well, right?
I think Sarah said, oh, I forgot right now, because they have online, they have virtual, and then they have an instructor led. I'll be honest, I have no idea.
I don't know. I was under the impression that all of that classroom classes are Zoom right now.
Gotcha.
Until things change a little bit. But yeah, I love teaching in person because then I get to interact with you and actually show you on the chart. This whole teaching online and trying to show you the chart has been definitely a learning curve.
I can't just like show it to you like that.
Imagine.
Yeah, and that's the hard part for me is I could show you on mine because I have it set up, but most of you guys are not don't have a document camera set up and could show me what you're doing unless you take a picture with your cell phone and send it to me or something, which some people do. It's just adds a little bit more of a challenge to the class where I usually just walk around and we practice all of our navigating skills together as a class, but we do what we can in this weird year.
I have a really silly question.
Yeah.
Like really silly.
Okay.
So in the kit they sell for the class at the store, this little guy is a lot bigger. Like this little guy that I have, because I just have it, he's what, 4 inches, and the one at school is twice his size. Do I need the one that's really big?
No, I would say you don't need it. You need something to measure distance, which is that tool that you have, and then something to measure angle or course or azimuth, which is going to be that a parallel ruler,
Yeah,
a
I have that.
or a triangle, something like that.
Yeah, I have all that. Okay.
So anyone that you have, you just want to practice with it. So that's what we're going to be doing a lot of in this class is get comfortable with the tools that you have. Whether you want to try out a new tool that you haven't used and practice with that. Some people like to do that. They're like, oh, I only use the parallel ruler because that's what we have on the boat, but I want to learn how to use a triangle or something. Then they change it up for the class. But whatever you have, try with that and get that muscle memory with what you have because that's what you have. You can buy, so many expensive nav tools. If you go to West Marine or Captain's Nautical, they have everything you can imagine. But whatever you have available to you, go with that. All right. let's dive into it again. Okay. So we are going to dive into kind of our chart orientation, looking around the chart and figuring out where things are. So on my PowerPoint here, I think I kind of go back and forth between the training chart and the local chart that we are using in this class. I know this picture isn't quite, it's a little blurry, I guess, on my screen, but this is the training chart that Martha's Vineyard to Block Island. Again, it's East Coast, and it's one of the Coast Guard's training charts. It is a Mercator projection. Both of our charts that we are using are Mercator projection. And so for all Mercator projection, well, pretty much for all the charts that you can use, the top of the chart is going to be north. The bottom of the chart is going to be south. Right, east, left, west. So that's just a good basis to start off. Everything towards the top is going to be to the north. Everything towards the bottom is going to be to the south. So this can get tricky sometimes when we have a chart that is maybe kind of that portrait versus landscape. Most of our charts are going to be that landscape, but if you have a portrait chart, you might set it sideways on your table, and then you could get mixed up real easy which way is north and which way is east, south, and west, pretty much. For those of 100-tonners out there, one of the training charts, that Block Island sound chart, is one of those portrait instead of landscape, and it can be disorienting because you're kind of looking at it like this sometimes. But always towards the top of the chart is to the north. Okay, and then we have our longitude lines, right? Our longitude lines go north and south. So everything, if we measure against this longitude line, that is exactly north, because these are perpendicular lines. So we kind of have this compass or this reference point on all of these bold longitude lines. So I call them bold because on the chart there's only a few actual longitude lines, and this is the training chart. On the training chart, it's every 10 minutes of longitude that you're going to have this reference point of what is north and what is south. So that is a great tool to use. And then, hold on, I think we had a comment here.
Magnetic north, right?
No, this is true north.
No, this is true north.
Everything on the chart is true. So everything we put on the chart is in true, and everything we take off of the chart needs to be in true. But on our boat, we use magnetic or compass, depending on what kind of boat we're on. So we're going to get into that on week 3, on the differences between that, but everything on the chart is in true. So so we have that reference to true north 6 times on this Martha's Vineyard chart. So that's very convenient. On the bolded latitude lines, that is a marker or a reference point of east and west, because these are all parallel. So directly along this bolded line is to the east or to the west, and that's going to be our bolded latitude lines. So on this chart, we have 4 of them. We also have our compass roses. On this chart, we have 3. So we have 1 that's kind of up here on the land, and then we have 2 in the water. So that is also a reference point of how we can find our courses or angles or azimuths by using those compass roses. But again, there's only 3 of them, where I like to use the lines because you have them more frequently. Okay. The compass rose, the outer circle on the compass rose with the big star, that is your true degrees. And that is true on the chart. And it kind of mirrors what a compass looks like. I know a lot of recreational boaters have those bubble compasses that don't really look like this, but the compass rose is kind of mimicking what your compass on the chart will look like, or compass on the boat, excuse me. The inner circle of the compass rose is magnetic. That is pointing to your magnetic north. So that 0 with the angle, that's pointing to your magnetic North Pole, where the 0 with the star is pointing to true North Pole. So that true North Pole is kind of that geographic, if we have the equator and it's cutting it in half and where all those longitude lines meet, that's the North Pole. That's going to be our true north. Where actual North Pole, or the magnetic North Pole, is kind of moving around. Again, we're going to go over that much more into detail at week 3. But that's why we have 2 of these circles or compasses on here. We have the outer one is true and the inner one is magnetic. We also have fathom lines. Yes, Billy, there's 15 degrees. Well, on our training, yes, on our training chart, there's 15 degrees variation. So on this example, there's only 4 degrees of variation. And I think on our Long Beach chart, I can't remember, was it 9 maybe?
12.
12. So there's a little bit difference. But again, we're going to real dive into that on our compass error week. Okay, so I won't get too hung up on it now. And then you also see on the chart these squiggly lines. So you see, and I call them fathom lines or sounding lines, fathom curves, different things, I guess you could call them. But these actual numbers are depths. And then these lines show the curve of what that depth is. So in this case, it's 400 fathoms. So everything offshore is going to be deeper than that 400. The next line I see is 300. So everything between the 400 and the 300 is in the 300 somewhere. And then you have the 200. Maybe I'm not reading that right.
I'm sorry, this might be a dumb question, but would you do 6 times that number to get the number in feet?
Yes.
Okay.
And there is also a little graph chart on the bottom of the chart that is very easy to convert. So you want to you want all of your data to be in what you're going to use. So if you have a depth sounder in feet, but your chart is in fathoms, it can be very confusing. So you want to know what is what, and not
right.
just have it.
So then to basically check yourself, you just multiply that number by 6, and
Correct.
then you get the actual one, even if your readers is wrong and says it in feet.
Yes.
Okay, cool. Thank you.
So I like to look at these fathom lines. Was there a question?
High tide? The depths are going to vary based on the tides.
Correct. And we dive into tide in Coastal Nav 2. But we're not going to dive into it in this class. We're kind of like, for this class, we kind of like start navigating in this bubble of perfection where we don't have set or drift or wind and current. We set a course and we're doing that course and it's all great. And then CoastalNav2, we kind of add in like realistically, we're going to have set and drift and tide and current and how to calculate those and apply those. So we kind of learn our basic nav skills in this perfect bubble that we have for CoastalNav1. So yes, I completely understand that there's all these other things involved and navigating is an art form and we are adapting to it, but we're kind of gonna hone in our skills in this perfect kind of world, if bear with me on that. I guess moving to my thought on these fathom curves are when you just look at the lines instead of like honing in on the numbers, it can show you, and I don't know if you guys can see, behind me is a map of the ocean and the heights and the curves and how that can affect things. So right here, because these fathom lines are close together, that means they're changing in a very short distance. So you have this steep slope on the seafloor, which can affect what's happening on the top, right? You might get different waves, different currents, different oceanography things that are happening on the surface that are affecting your boat. And then you can also get these little, not islands, but little seamounts on the sea floor that can bring up more wildlife. I'm sure we got a few people here working on sports fishing boats. You know where all these little underwater islands are because they have more wildlife. And sometimes the wildlife follows the steep curves of the seafloor and things like that. So those fathom lines are great indicators. We also can use them as line of positions, but we're going to get into that again later. But it's just good to know of what those squiggly lines mean. So it's an even number. So let's see, right here we have 16. So this fathom line is 20. So everything along this fathom line is 20 fathoms. And then we have another fathom line of 50. Everything along this line is 50. So anything further offshore is going to be deeper. Anything further inshore is going to be shallower. Okay. That's fathom lines. Oh, these are the fathom lines for Newport. I think that's what I'm showing here. Okay, now we get into, we're touching a little bit on tides. Again, we're going to dive into tides in CoastalNav2. But what we're going to talk about here is our chart datum. So datum is just kind of a reference point or a reference point that we're springing off of, a base point, baseline, if you will. So modern baseline or chart datums is going to be your MLLW. That means mean lower low water. So they take all averages of the tide and sort it out into high waters and low waters. And then the low waters, they're going to average those out and separate it into the lower of the low waters. And that is going to be what our baseline is. And that baseline is what's printed on the chart. So all of those little numbers, all of those little soundings are of a mean lower low water. So it's really erroring on the side of caution there. It's giving you a lower low water average of what the depth of water is there. Then we apply our height of tide. So we can use it from calculating it from a little tide book or a actual tide book, or an app, a computer, website, whatever you're using to tell you what the tide is, you're going to apply that number to what the chart says. So if I go back to here, and let's say I have a 2-foot tide in Newport, I'm applying those 2 feet to all of these numbers. So I just am adding or subtracting, depending if it's a positive or negative tide. You're applying it to what is given on the chart. So we have our mean lower low water, and then we have the height of tide, and that's the actual surface of the water. Then I want to note for things on the land, all of those mean low waters, chart datums is for things within the water. Things on land, your bridges, your lights, distance or heights of things, that is going to be from your mean high water. So that's erroring, I can't say erroring on the side of caution again, that we want to assume that there's less vertical clearance than we actually have. So we have our vertical draft and our water draft. So for things on land or in the brown golden areas, that's going to be from mean high water heights, where our depths in the water are going to be from mean lower low water. Now, this is another picture of it. As a caveat here, the old chart, meaning the training chart, is from just mean low water. They didn't have the mean higher high water or mean lower low water when they made that chart. So I think there's a question on homework that says, what are your chart datums? All your modern charts are going to be that mean lower low water, where the training charts for the Coast Guard are mean low water. So just keep that in mind. I guess I'm making it more confusing than it needs to be.
Bree?
Yes.
So a datum refers to the number on the chart of the depth.
The datum is kind of that baseline.
Right. It's
so on the excuse me. So this is kind of the title of the chart, and it says your Mercator, your scale, your soundings, and then it says at mean low water. So your soundings are in feet, and the datum is mean low water. So it's just saying that all of these numbers that you see in the white, there's tons of numbers in there. Those soundings are mean low water, where our modern chart datum is mean lower low water. Okay. So we're going to dive into this more. So that chart info block, we have the title of the chart. So our training chart's title is Martha's Vineyard to Block Island Sound, and then it's including Western Approach to Cape Cod. So that is the title of the chart. When you are asking somebody for a chart or purchasing a chart, putting together an order, if you're going to go from San Francisco to Newport or something, you're like, oh, I need all these charts on board. What are my charts? You can go with your chart number, which is this, that's going to be on the side of the chart. It's going to be on each corner. So you have your chart number here, chart number there, chart number there. Maybe it's not on the top right, but it'll be in the corner, and it'll be in that pinkish, purplish color. So that number is just an identification number. It's not a measurement of anything. It's an ID number, basically. It's chart number. And then you also might want to put in the chart title. If you're anything like me, I mix up my numbers sometimes. So it's good to write in the number and the chart title so you can double check what charts you're ordering. So there's our chart number. Also our chart numbers, so it's just an ID, right? It's not a actual measurement of anything or have to do with latitude or longitude, but they are related to each other. So this one's 1210TR. If you look at, if anyone's looking at these, you kind of see this little chartlet right here where it gives you other charts in the area. They're going to be close to that number. Maybe 1215, 1220, 1230. So it does, when you're looking at charts nearby, they're all going to be relatively close in number when you come to the chart number. That 18746 is the Long Beach chart or San Pedro Channel chart that we use. Then you have your 1848, 1850. Those are going to be, you know, our local charts that the numbers are kind of close to you. So that's your chart number. Here's your chart title. That's going to be that Martha's Vineyard to Block Island. So it's always good to write that down. You have your seal, who made the chart, NGA, NOAA, who made it. You have your chart projection. So is this a Mercator projection, mnemonic projection? What type of projection is this? And what scale is it? We are going to dive into scale further in this PowerPoint. But projection, we already went over. And then you also have your soundings in the unit. So it's either in meters, fathoms, or feet. And then you also have on the chart, kind of in bold, I guess it's not too many places on this training chart, but it should be in bold at the top, at the bottom, maybe on the sides, soundings in feet. And it says it in the chart block, soundings in feet, where our Long Beach one is soundings in fathoms. So it's always important to know what unit of measurement you're looking at here for your soundings. And then it will tell you the chart datum. So again, our training chart is mean low water. Modern charts are mean lower low water. Then you also have the addition and the notice to mariner. That's NTM. Your notice to mariner is the publication that comes out that gives you corrections for the chart. So on the chart, maybe they moved a buoy or they took out a buoy. Instead of issuing a whole new edition, they're just going to issue a correction. And so you want your chart to be up to date, to be corrected. So if you are going on a new voyage and you're ordering a bunch of new charts, all your charts are going to be printed on demand and updated. So that is great. If you're using an older chart, maybe you had this, you know, your Long Beach chart in there 3 years ago or something, and you're like, hey, let's use it again. Maybe I should make sure there hasn't been any major corrections. You want to look up the corrections for that chart and make sure you have the correct edition. Once it gets to a point that there's lots of corrections and it's not like an annual thing, but they will issue a new edition without giving a bunch of new corrections. So, so you always want to make sure you're on the latest edition and you are corrected to the most recent notice to mariner. And I'm going to be showing you on our pub section of this how to find those notice to mariners and what edition is the latest for that specific chart. But where to find what edition and what notice to mariner is going to be on the bottom, the bottom left side of the chart is going to have your edition and your notice to mariner. This is a training chart, so the notice to mariner thing is kind of weird. Like, I don't know what the 62 versus the 90, it's a little strange on this one. But I would look at your Long Beach one. Mine's upside down, so I can't see it right now. To see your edition, and a lot of times their notice to mariner is an actual date, not this week, but we will go into that as well. Oh, here we go. This is one for the 1846. It's the 40th edition. It was last corrected on April 5th, 2019, but it has been cleared through, meaning up to date through the latest notice to mariner for the local notice to mariner, 1120 and 1220. So that makes sense. Again, this one is a little bit confusing. But I also wanted to notice on here we have a Loran C overprint. So on all of our training charts, we have this Loran C overprint. Hold on, there we go. Our Loran overlay. So if you could see, there's these lines that are not latitude and longitude lines, but they're kind of angled. There's 3 sets of angled lines on this training chart, and that is a Loran overlay. So we have our X's, our Y's, and our W. Loran C is not maintained anymore. There might be some, I've heard of some from students that have still using Loran C on the East Coast for some fishing vessels, but they must be privately maintained. The government does not maintain any Loran C stations anymore, so they're not overlaid on any more charts, and you won't be seeing them. If you're using a training chart, of course you have this Loran C overlay. There are no more Loran C questions on the Coast Guard exams, but you do have these lines that are just super distracting and can be confusing and disorienting. So that just makes it real fun to train with the Coast Guard. Anyways, that's our Loran overlay. So again, these numbers and these lines, we are not going to be using, but you will see them on the training charts. Okay, so I just wanted to, we had our edition notice mariners, our chart number, and then it told us here we have a Loran C overprint. Okay. Now we're going to look at our latitude and longitude lines. So our latitude lines, again, are those parallels that run horizontally on the Earth, right? So it goes through the equator. And then our latitude are parallels that go from 0 to 90 to the poles. When we are looking at measuring them or plotting a latitude line on the chart, we use the far side. So we are going to use that vertical side, right or left, to tell us what the measurement of the latitude line is. So on this training chart, we're at 41 degrees. And so we have 41 degrees, and then we have 10 minutes. And then the next number we have is 15 minutes. Next number we have is 20 minutes. So it's increasing, going up, meaning we are in the northern hemisphere. If it's increasing going down, that would mean we're in the southern hemisphere because it's getting away from the equator. And so we have, we have our degrees. And then we have our minutes. So we have 20 minutes and then 25 minutes, and it's kind of black and then white, black, white, black. So that kind of differentiates. And sometimes I like to write in right here, 21, right here is 22, right here, 23, 24, and this is 25. So I know exactly where my minutes are. And then if I look at 1 minute of latitude, which is equal to 1 nautical mile. So 1 minute of latitude equal to 1 nautical mile. I could count these little ticks, and there's going to be 10 of them. So this is tenths of a minute, or tenths of a mile. But yes, tenths of a minute, because these are divided into 10. So I can have 20.3 minutes, 20.8 minutes. And I know exactly where to measure that. So that's going to be our measurements of longitude, and then we can draw the longitude as a horizontal parallel to the equator line. But we measure the distance from a reference point, which is going to be these bold lines, right? These bold lines are our reference points, so we can measure what that latitude line is. And next week, we are going to be practicing the whole time on plotting our latitude and longitude lines. So look forward to that. For longitude lines, our longitude lines go vertical. So we use the top and the bottom of the chart to measure which longitude we are at and to get the difference of longitude between these. Again, these numbers here are not equal to a nautical mile. They're longitude. So we have, again, a degree, and then so that's 0 minutes, 5 minutes, et cetera, and then we have our tenths of a minute. So this is 1, 2, 3, 4, 5, 6, boom, boom, boom. And this little number is divided up into 10 little segments, so that would be tenths of a minute. So we have degrees, minutes, and tenths of a minute on the chart, and so that's how we are going to write it in our worksheets. Again, you can see if the numbers are increasing to the left or increasing to the right to see if we are in the left, or to see if they're in the Western Hemisphere or the Eastern Hemisphere. Okay. Any questions on latitude and longitude? Making sense a little bit? Okay. Okay, and then we have all over the chart these notes. These notes give us extra information, as if there wasn't enough information on the chart already. So instead of putting a paragraph in a little tiny area, they'll say, see note A, or see note something or other. And then we have to do this hunting, scavenger hunt of where is that note on the chart. Most of the time, that note is going to be somewhere in the land, and sometimes it's completely where you don't expect it. So it is this hunting of where they found a little spot to put the note that they are talking about. So they might give you a clue here, prohibited area, see note A. Note A is referring to some other nav pubs that have the actual rules of what to do in a prohibited area. This is a little print or little cutout here of the approach to the Long Beach, LA harbor, where you have a bunch of notes. So Los Angeles pilot area, see note B, D, and E. Security zone, see note A. Precautionary zone, see note B. Long Beach pilot operating, see B and D. So you have all of these notes, and those can tell you information. So that's note D is telling you what channel to call the vessel traffic system, VTS, giving you just much more information instead of putting it just in that chart and cluttering up that chart. So it's good to, if you are operating on a certain chart, to read the notes and see what they're referring to. If it says go to a coast pilot or light list or something, go to those and see what it says. See what kind of regulations or rules are in that area. So again, that notes are kind of this hunting. They might not make sense of where they are, but they're going to be stuck in the land somewhere. So notes. Okay. Then we have our distances. So I like to use our distances as the latitude scale. So you can use your distance as latitude scale, but there are two places on our training chart that have a distance scale. And that's going to be down here at the bottom. And both of these distance scales are horizontal. So I like to point them out because you are welcome to use these as distance scales. And sometimes it's good to check if you get confused. Does my mile work on this distance scale's nautical mile? But I just want you to be careful because it is very close to the longitude scale, which is not nautical miles. So if you're going to use the nautical mile scale, make sure you're not using the actual longitude scale. And they're in different places on each chart, where again, your longitude line, your latitude line scale is on the left and right side of every chart, every Mercator projection chart you're going to be working with. So I recommend getting used to that instead of searching for your distance scale, but they are there. If you want to double check something or you're confused, you can use that distance scale. Now on this distance, well, I'm gonna get it. Yeah. Okay. We also have references to larger scale charts or joining charts. So if you are sailing off of the chart, it might tell you on the side to join, gives you a chart number instead of a title. It'll just say the number there. Oops. Okay. And then some charts will have this little chartlet or this little picture of the chart itself and put these little magenta, pink, purplish squares around it to say, oh, if you are navigating up into Buzzards Bay, once you pass, 71 degrees longitude, you're going to want to change to 13230 chart for a larger scale or zoomed in, more detail information on that chart as you navigate up Buzzards Bay. So that is very helpful when you're in your voyage planning stages of what charts to pick out. Okay, did Lorraine? Okay, so scale of chart. So the scale is a ratio. I don't have it on here. So let's see. Both of our charts that we are using there we go. Both of our charts that we are using are a one, okay, that doesn't work. Are a 1 to 80,000 ratio. So what that means is 1 unit, so 1 foot, 1 inch, 1 unit of measurement on the chart is equal to that same unit on land, or on the earth, not land, on earth. So if I measure, where's a ruler? There's a ruler. If I measure, 1 inch on the chart from this point to this point, that is going to be equal to 80,000 inches on the earth. Does that make sense? So it's giving you a scale. So it's kind of a ratio of 80,000, if I did it this way, where we get into our harbor charts. I'm going to get this right. I don't have it on here.
Wait, so 1 inch on the chart is equal to 80,000 inches on land?
Correct.
Okay.
Sorry, hold on. Okay, so a harbor, or like zoomed in, if you will, is going to be 1 to 20,000. And a ocean chart might be 1 to 5,000. Are you guys still seeing my my whiteboard?
Yeah.
Okay. So we might say an approach, or coastal. I'll call it coastal. Was 1 to 80,000. So we have this term of large scale or small scale. So it can be confusing here because these are numbers, right? Where 1 out of 5,000 is going to be a bigger piece of the pie than 1 of 20,000, right? That is going to be a smaller piece of the pie. I have that right. I have that right. So this is going to be, no, that's not right.
Hey, Bree, this is Colleen.
Yeah.
How come the ocean chart is 1 to 5,000? I thought it would be like 1 to 150,000. What am I missing? I got something wrong.
I think you're right. I'm going to look it up right here. I don't have my numbers on my but I'm going to get the official number here. Hold on. Okay. This is our chart, Coast Pilot. You guys see? We have trying to focus it for us. General charts, harbor scale, sailing charts. So our sailing charts, yes, I had it wrong. Our ocean, covering the ocean charts, has a greater number, meaning smaller scale, where your harbor chart has a smaller number, meaning larger scale. So let me rewrite my paper, my whiteboard. Now I gotta zoom out here.
Is that because the ocean's so vast that it's focused on more, and then the harbor one is on a smaller is on a smaller scale because it's a specific location?
Yes, so you have that zoom, your scale here is a ratio. So we have sailing, which is ocean, covering a whole ocean or whole, maybe from here to Hawaii or something, maybe not the whole Pacific, but a certain sailing region, is 1 to 600,000. So that makes more sense. 1 inch on the chart is 600,000 inches on land. And then you have your harbor chart, which is 1 to 50,000. So that's much, and we call this large scale or zoomed in. And this is small scale. So as you can see, my confusion, and it is confusing because the small scale chart shows a large piece of land or large piece of ocean, where the large scale chart shows a small body of water, a harbor, but it gives you much more information, detailed information on that harbor. So I forget what the rule it can't quote it exactly off the top of my head, but it's something like this is a CFR, so the Code of Federal Regulations require your vessel to have a appropriate size scale. So it's pretty much the largest size scale you could have for that region that's also corrected up to date. So if you're using a chart of the whole Pacific to make an approach to LA, that would not be practical because it doesn't give you that detailed information as you're approaching LA. You want to go to a larger and larger scale as you're making an approach to a harbor. Which, bring up this. Is going to be our examples. So our small scale or ocean chart here gives us the whole Gulf of Alaska. So if we are, crossing the Gulf of Alaska, we're going to be using this one. But our, our distances are real small on here. So as we are making an approach going up to Valdez, you want to use a larger scale chart. So you can go larger scale where you see the whole traffic lanes as you make up your approach, and then go even larger to just the zoomed in version of actual Valdez. And then they go even larger for what that, that channel looks like and the detail oriented there. If you're using a electronic plotter, it's going to automatically change the charts. So it changes the chart if you're sailing off the chart, and it changes the chart depending on the scale of where you are as well. So typically you don't have to worry about that if you're using electronic plotters, but if you're using paper charters, you want to not forget. So maybe draw a line on your chart to say, hey, once we pass this latitude, so if I'm looking at these charts right here, once we, make this turn and pass this latitude, I want to change to this chart. So pull a new chart out of the chart drawer so that I can have more detailed information. So that is, a physical change that you should do when you're working on your paper charts. Does that make sense? I know I made a mistake there and probably confused you guys, but that's the way it goes.
Hey Bree, I wonder if it's worth me just mentioning here for recreational boaters with electronic chart plotters, it'll only automatically change if you have paid the money to buy the appropriate chart pack. So often electronic plotters will not change and will give you a lack of detail that you wouldn't lose if you had the paper chart.
That is very good to know. Yes, where that is my my spoiledness in the commercial world. We would purchase all of the charts and we would have those because the company did that for us. Where as a recreational boater, you need to purchase the charts for your specific electronics for where you're going. So thank you, Ted. Very good point.
Welcome.
Bree, just
yes.
real quick on the electronic charts as well. Found out in Captain Prelow's class this last semester, the electronic navigation chart that I was using in Newport Harbor did not have the number 12 beacon on the electronic chart. That beacon's been there forever, but it did not show on my electronic chart. So again, double check the electronic apps that you are using.
Yes, it's very good to you know, have both. You know, you have your paper chart, like your electronic chart, your radar, your GPS, and all of these things. You don't want to you know, get that tunnel vision of only using the radar, only using the GPS, only using the chart plotter, only using paper. You know, you want to use all of these tools to help your situational awareness, to really help figure out where you're going, where you are and where you're going. So yes, very good point. Don't completely trust one thing. Okay. Okay, now we're gonna dive into pubs. Hold on. We're gonna kind of do this a little bit quickly. We have about 40 minutes left, so bear with me here. So we have a chart 1, which is kind of our legend or our key of the charts. So your chart 1s can look different. So mine looks like this. The one at the at OCC's bookstore is spiral bound and it's landscape mode, but all of you have on the training chart, chart 1, printed on the back of a training chart. So if you flip over the Martha's Vineyard chart, you are going to see chart 1 printed out page by page. So that's just a great print that we have for this 1210 TR chart. That chart number 1 is printed on the back. But I just want to note that if you're using a book, it doesn't exactly match up. Like this book doesn't exactly match up with the spiral bound book, which doesn't exactly match up with the printing on the back of the training chart. So if I say, you know, go to page 56 or N number 2 or something, it's not going to line up exactly with your friend's chart 1, depending on which chart 1 they are using. So just keep that in mind. I know the homework can be frustrating. One of the homeworks today is going to be using that chart 1 to find what different symbols mean. But again, it's kind of this hunting, familiarization, looking around for something. How chart 1 is organized is by kind of general topics. So we have, you know, P is our lights. Then we have buoys and beacons. We have, you know, nature of the seabed. Is it rocky? Is it sandy? What's on the seabed? We have depths. We have obstructions, wrecks, rocks, pipelines. And then we have a whole section on, you know, routes or tracks. So we have different sections of so this one goes A through X. I guess the one I have up there goes A through U. Again, they don't match up perfectly. But that's how they're organized. So when you are looking for a symbol on the back of the chart, on chart 1, it kind of goes in that category of, are we on land? Are we in the water? Is it helping us navigate? Is it helping us, you know, aid to navigation? What topic is it? And that's going to give us more detail. So that is our chart 1. It's always good to have. I've also in the Google Classroom copied a digital format of chart 1. So a lot of times they'll have that as well. And sometimes on your electronic plotters, there is a tab that you can look at your chart symbols, or even maybe Ted knows the answer better to this, but on chart plotters that I used, you could just put your cursor over a certain symbol and it would give you the information of what it was, what its name was, and all of that as well. So again, there's, you know, hundreds of varieties of chart plotters, from very, very basic to very, very advanced. So somewhere in between, they are capable of amazing things. But again, this class is focused on the paper section. So doing it old school, if you will, by using the paper chart 1. So that's what our exercise is for homework this week. Okay. So chart 1 again here. So J was nature of the seabed, and it has the symbol of what it is on the chart, and then its description. So nature of the seabed is, what is the seabed? Are we, you know, anchoring in mud? Are we anchoring in clay? What does the bottom consist of? We want to know that if we're anchoring, if we're using, you know, a fathometer, that can have different readings off of different seabeds, etc. So good to know. And those are going to be letters on the chart. So if we're looking for what that letter means, we'll go to J, nature of the seabed. Our natural features, I'm kind of going to click through this. Also, I really like in the chart 1 is the list of acronyms that can be helpful across the board on deciphering some of the acronyms. Again, in navigating, there's tends to be a lot of acronyms and it can be confusing. So Bowditch, Dutton's, and chart 1 have great kind of acronym lists that I like to reference. So if you get confused, try out one of those glossaries or index of abbreviations. Color is a big thing on the chart. We have a couple different colors. Oops. So here we have our, let me just go to the, no. Okay, so I'll just go with deep water is going to be white. So the majority of our chart is white, and that is deep water. As we get closer to land, we get a dark blue color. And then we get even closer and we get a light blue color. And then we get even closer and sometimes we get this green color. So that green is going to be affected by the tide. So it can be sometimes land and sometimes covered by water. So all of these green areas are going to be affected by the tide. Sometimes you'll see it, sometimes you won't. And then this gold or tan, beige, whatever you want to call it, is going to be that land. So if we look at our entrance to Newport, We have some areas that are green along the coast. Those are affected by tides. And then we have our shallower water, which is the blue, and then our deep water as the white. Now, a lot of times with electronic charts, you can change those colors. So if you are, you are on a boat that you're, no go, I don't want to go any shallower than, say, 15 feet instead, or this is fathoms, whatever, 15 feet instead of 20 feet, you could change your color to only color the 15 feet instead of 20. Again, some electronic plotters have this, some don't. I always like to change that on the ones that I was using. I don't know if, I don't know, maybe Ted, you can answer that. Do you change that on the ones that you were using?
Yeah, and so there's a long answer and a short answer. So I prefer to use a chart plotter which will load NOAA charts directly. And so some chart plotters use raster and some use vector charts, and some are configurable and some are not. So I don't want to steal your class and go into electronic nav. So
yeah.
you've got to know your navigation instruments.
Yes, and the capabilities of them. But on the chart, the paper chart, it's going to be set, right? We can't change it on the paper chart. So this is anything shallower than 20 is going to be that light blue. And then the green is affected by tide. And then we have that gold as land. This is this is just an example of some areas have those different colors of blue. So they have white, the light blue, and the darker blue as it gets shallower and shallower. So sometimes you have that variation. On the charts that we are using, we don't have the variation of blues, but some charts might. And then this was an example of your approach to New Orleans. When you're going through the bayous there, they have a lot of that green area that affected by tide. Sometimes this is all going to be exposed and sometimes it's not. So a lot of the charts we're using, we don't have much of that green, but it does exist, I promise. I guess my point on that. Okay, we're gonna keep moving forward here so we get through this. Lettering, the lettering or the font of how this each word is gives us information as well. So letters that are vertical, or your standard letters, are fixed objects, meaning they are attached to the ground, to the sea floor. They are not going to be moving at all. So those are our lights. And anything on land is going to have standard or vertical lettering, where things that are affected by tide, like our buoys, are going to have that italicized or slanted font or lettering. So that just gives you some information just by looking at the text. Is it a fixed object or is it not a fixed object? In navigating, we would prefer to use fixed objects, although we can use these buoys, things that are affected by tide, but we just want to keep that in mind. Then we have our three major symbols that we are going to be working on this class. We have our light, which is fixed. Again, it's on the seafloor and it has that straight lettering. And then the dot, or the little circle, is where that object is. This little teardrop shape has direction, has no significance. It's just where it's not going to be in the way of something on the chart. So it's a dot with a teardrop telling us it's a light, but the direction of that teardrop has no significance. Again, this dot is solid. It's filled in. So that gives us that kind of reminder that this is a fixed object. It is a solid dot, where our buoys are affected by tide, right? They're anchored to the bottom by some sort of anchor, and then they have some sort of road, chain, wire, rope, something that is then connected to something floating on the wire. So it can be affected by tide. It can move around a little bit. That is going to be an open circle. So it's not a solid dot. It's going to be an open circle. And then it has a diamond attached to it. Again, the direction of that diamond has no significance. It's just the symbol of the diamond is a buoy, something that is floating on the water but anchored to the seafloor. If it has this magenta stamp on it, that means it's a lighted buoy. So it has some sort of light characteristic that there should be a light on that buoy. Where if it's just the buoy symbol, there is no light on it. And next week, we are going to dive into all aids to navigation. So we're going to be looking at examples of all of these. But these are 3 symbols that I am really going to be locking in your brain, of a light, a buoy, and a lighted buoy. So we want to really correctly identify what we're looking at out the window and what we're looking at on the chart. And these symbols really help that. So when we're navigating, we want to really correctly identify what we're looking at out the window and what's on the chart. So is it fixed? Is it floating? Does it have a light? Does it not have a light? All of these little symbols can help us identify it.
Bree?
Yes.
Why aren't the lettering of the buoys slanted? Or because they're affected by tide?
Yes, buoys are slanted.
Wait, you're saying they are slanted?
Yes, it's a slight slant. But if you can see, these ones are very vertical and these ones are slightly slanted. It's just like the italicized, font, if you will. It's not a drastic, but it is a little bit slanty.
I'll check it again in the morning when my eyes are better. I don't know.
Okay, cool. Okay. Then we have a couple more symbols we're going to go over. We have day beacons. Again, we're going to go over what day beacons are next week. But we have a triangle and a square, which is actually a day beacon of a triangle or a square. And then on these buoys, right, this is a buoy. These are all the same symbols, but next to it, it has a little indicator that N would be that the buoy is in the shape of a nun, or the buoy is in the shape of a can. And again, we're going to go over what the difference between a can and nun buoy are next week. And it can also give you colors. Is it a red or green or yellow or white, red and white? What color of the buoy it is? All of those little letters next to the lights or the buoys or the day beacons mean something. So it's good to kind of keep in your head what those mean instead of having to look up in chart 1 every single time. Oh, what does that Y mean? Or what does that C mean? It's all trying to help you correctly identify what you're looking out the window and what's on the chart, so you can really get that better situational awareness of where you are on that chart versus looking out the window. Okay. We're going to just jump in here to NavPubs. And again, I've tried to put some more slides in this section, but when I teach this in person, we actually pass around the pubs so you can see them all. Again, I apologize for all the pubs that we can't see. in Zoom, but we're gonna do the best we can. So rules of the road. Does anyone know off the top of their head which vessels are required to have a rules of the road book?
Inspected vessels?
Inspected vessels, yes.
All of them.
All of them should, but some don't.
Is it 40 and above?
You know, I asked the question and then I don't know the exact answer.
I think the answer might be any vessel over 16 feet in length.
Okay, I was going to say it's a length, 16 feet in length. I was going to say like 20 feet or something
like that. Yeah.
It's a length, yes. 2016, I don't know exactly what it is, but if you're over a certain length, you need to have rules on the road. You should have rules on the road. In any case, maybe just have one at home so you can become familiar with it. There's great pictures in rules. I teach a workshop on rules of the road. I think it's covered in a bunch of other classes as well. You really just want to be familiar with what the basic rules of the road are. And, you know, you don't need to memorize every single rule of the road. They can be very lengthy, if you will. But where do I find it and how is this book organized?
Pauline just posted it's mandatory on vessels over 12 meters.
12 meters. Okay. There we go. Got it. I also like this Rules of the Road book by Steve Brown. It has the actual rules on one side and then a layman's terms, if you will, on the other side of what that actual rule means instead of the law language that it is printed out as. So I really like this Rules of the Road book by Steve Brown. He was actually my instructor at the academy. That's why I have his book. But it was a great tool. Again, you always want to be familiar with your rules book. And that is a pub, meaning it can be corrected. So you can see here it includes notice to mariner corrections, blah, 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 blah. So it is a navigation pub that can be corrected.
Can you purchase that at the school?
Yes.
Cool.
Then we have a chart catalog. So for our US charts that we're going to be using, our chart catalogs kind of look like a road map. You kind of like try to figure out how to fold it and then it like folds all back into one page. But it has a map of whatever region it is. This is the Pacific Coast. And then it has that information and those little squares of your chart number, the title of the chart, and the scale of the chart. So if you are making, you know, a voyage plan from San Francisco to LA or wherever, you can use these chart catalogs to help you figure out which charts you need. Again, there's, you know, digital copies of these. But if you want the paper ones, if you're underway and you're making an approach to somewhere, if you want some more charts, you know how to order them. Chart 1, that's another nav pub we want to have on board. Okay, the light list. So the light list is exactly what it is saying. It is gives us information on all the lights as we are approaching somewhere. So if we are at sea and we are approaching LA and going into, you know, Pier 60 or something, it is going to give us the lights in order. So it has a number. This number is just an identification number. It does go in order as you are making an approach, but it has the name of the light, it has the position of the light, and then it has the characteristics. So that is, how often is it flashing? Is it flashing evenly? Is it flashing unevenly? What color? Is it white? Is it red? Is it green? Is it yellow? And then it gives us the height. How tall is this? We're going to touch next week on visibility and how you want to know the height of the light to see how visible it is. And that range also tells us how visible it is. Again, we're going to go more into that next week. And then we have what the structure looks like and some other comments on the light itself. So if you want information on a light, the light list is where you're going to get it. The light on the chart is going to give you maybe the name and then the characteristics and the height and the range, but it might not give you all this other information packed in on the chart. So if you look up your lights that you are going to be navigating off of, you know the exact position, so you can make sure the light that you're looking at is the light that you're looking at on the chart, and then those characteristics as well. For those of you 100-ton or Coast Guard exam students out there, the Coast Guard refers to the light as a name. So you're going to be taking a bearing off of Long Beach light, but all of their questions are on the East Coast. So you're going to be taking a bearing off of Breton Reef light. But if you don't know where Breton Reef is because you've never navigated on the East Coast, you can look it up in the light list and get the actual position to easily plot it on the chart and then know where it is. So that is a great time saver instead of hunting around on your chart to figure out where Breton Reef light is. Just a little tip there.
Where's the light list located?
That is a pub. So I brought out, when I was trying to figure out my scale, it is just a publication. So as a 100-ton tester for the U.S. Coast Guard, you are using the pubs from 1993 because that's what you can, but you want to have the latest light list on board for your navigating purposes. So they get issued each year. So there's a new 2021 light list. You want to have that on board so you can look at the latest editions of the light list. So it's just a separate book that you have on board with you. And you can also just download the PDF, and I'm going to show you where those PDFs are as well. With PDFs and electronics, you need power. So if for some reason you lose power on board, then you don't have that book, right? So I love the PDFs because you could just, Control F and search for something, and it's great. But it's also good to have the paper version.
So there's certain pubs for certain charts, pretty much?
Yes. So the pubs go in regions. So our light list is for the Pacific Coast and Pacific Islands, where our Coast Pilot is for Pacific Coast of California, Washington, Hawaii, and Pacific Islands. So it shows you in the front of what region it's covering. So you go with the volume, which volume you want for your specific area.
Got it.
So light list is the United States light, or all of the lights in the United States. If you are going down to Mexico or Canada or anywhere else foreign, you need the list of lights. So we have the light list for the US, list of lights for international. So I think I show here, Mazatlan has one of the brightest lights, I think, on like the whole Pacific West Coast. Its range is 33 nautical miles, which is very, very far. So it just gives you information about that. But list of lights, again, is international. Light list is the United States. Then we have our Coast Pilot. Our Coast Pilot is a great addition to the chart itself because it gives you a lot of extra information, extra descriptions. Oh, you're approaching Long Beach, you're going to see, you know, cliffs, or, you know, you're going to be near Camp Pendleton. Here are some rules and regulations about Camp Pendleton. Here are some dangers, or just some more information that isn't on the chart is in the Coast Pilot. So you have, let's see, this example, we have prominent features, channels, how to contact the Coast Guard, harbor regulations, bridges or dangers. We have a 5-mile-per-hour speed limit in Newport. So it just gives you more information that's not on the chart. And sometimes there's pictures and images. So it's another great tool if you are navigating in an area that you have never been before. Take a look at the Coast Pilot just to give you a little more familiarization of the area. And again, it's focused on mariners, right? So it's this familiarization focused to boaters who, you know, are new to the area. So that's the Coast Pilot. Now the foreign version of the Coast Pilot is sailing directions. So if you're going somewhere foreign, then you're going to use the sailing directions. Again, it's the same kind of thing. It's, you know, giving you pictures, familiarization, you know, channels on the radio to call, what typical tides or currents are, what typical weather patterns, you know, is it daylight saving? Is it not daylight saving? What zone time do they observe? Or what holidays do they observe? Are they going to be closed on Martin Luther King Day or not closed? Or on, you know, whatever holiday they're observing. So it gives you just tons and tons of information. So it's sailing directions for foreign, or Coast Pilot for for the United States. I just read your question. Does the OCC sell Coast Pilots? I don't know if they do. I want to say they don't have a huge amount of Coast Pilots for sale. I don't think they do. I get all of my nav things at SafeNav or Safe Navigation. It's on like 4th or 5th Street in Long Beach. I live in Long Beach, so again, it's pretty close to me. It's right down the street. But they have all the pubs, all the nav tools, study materials, everything you need at SafeNav. Captain's Nautical is, I think, in San Pedro. They have everything you could possibly need as well. So I use those. Again, those are more local for me. But let's see. Yeah, so I would go check out SafeNav or Captain's Nautical if you're looking for those. And even just online, you might be able to get it on Amazon. I don't know, but okay. So we had Coast Pilot, sailing directions. Then we have our tide tables. So we're going to dive real into this in Coastal Nav 2. But our tide tables have every date of the year and what the high and low tides are for each reference station. And then it has the list of substations and their corrections as well. Tide tables get issued annually. OCC gives out these little guys for the LA region. Again, these are also printable online or, you know, downloadable online as well. But I just got the 2021. So our Coastal Nav 2 classes are going to have our 2021 tide and current questions. So that's going to be good. But again, you don't need to actually get those pubs. if you don't want to, you can use the downloadable version, and I'm gonna have them printed off the pages that we're actually gonna use for class. So you don't need to get these. I just wanted to show you that, you know, if you're navigating in this area, it's good to have a hard copy on board, power goes out, or if you're just navigating old school. Okay, so we have our tide tables, our current tables, again, tells us when slack, ebb, floods, times, and velocities are. Then we have our Nautical Almanac. So that's another annual pub. Comes out each year. I got the 2021. We're going to use that in our celestial class, but if you are doing any sort of celestial navigating, you need your Nautical Almanac. So your latest version of the Nautical Almanac. Again, for celestial, you have your site reduction tables. These don't change too much, I would say. So if you have an older one, that's fine. Again, only if you're doing celestial nav. Then we have our distance between ports. It's literally what it describes. So this is, you know, quick voyage planning. If you're underway and you're like, oh, what's the closest port, or what's, you know, what's the distance from Mazatlan to San Diego? It's going to give you your distances between ports using popular junction points. So you have your list of junction points and then your list of distances to different ports. So again, it's just one of those nav pubs that you can use on board for, you know, quick navigating or quick voyage planning, but you don't use it too often. Okay, then we have our notice to mariners, and I have the link here for it, but if you just Google notice to mariners and then go to the one that says MSI, I think that's Maritime Safety Information, your MSI notice to mariners. And I'm going to show you that website momentarily as soon as we get to this PowerPoint. Oh gosh, we have 5 minutes. Okay. Okay, we're going to do this quick. Sorry. So on your notice to mariners, old school, they would print out the entire notice to mariners and deliver it to my ship. And so I'd have this big, thick notice to mariners for 1 week. And if I had been gone for 2 weeks, I'd have 2 of them or 3 of them. And then it has different sections. It has chart corrections. It has pub corrections. It has light list of lights, all those different sections on it. So I know there's a lot on this page here, but one thing that I always click on is your charts affected by the notice to mariner. And on this, it gives you the chart number, the latest edition, and all of the corrections for that edition. So if we're looking for 18746, which for some reason I don't have on here, we'll just do 18526. The latest edition is the 60th edition, and there was a correction on the 5th week of 2020 and the 11th week of 2020. So I want to make sure I have the latest edition and I have those corrections. If I go to those corrections, this is what the correction looks like. So the correction chart number, edition, the last notice to mariner, and then it says what the correction is. Delete this buoy in this vicinity with the waypoint. We have add a depth of 22 meters. We have add a visible sector to a light. We have delete a depth obstruction, delete a depth obstruction. So those are kind of what a correction could look like. It gives you the lat and long and the correction to make on it. You also have they call it chartlets, which I'll show you on that website as well. Instead of moving all of these buoys like a half an inch or something, they have these printable, and sometimes if you get the notice to mariner delivered to the vessel or something, they're stickers. They're actual stickers that you can just like take off and then stick on the chart, and then it's corrected. But I did a lot of printing out and then cutting and literally gluing to the chart instead of moving around those buoys. So those are the chartlets, if you're correcting the chart in that way. Pubs, these are our publications for notice to mariners. So you have, again, a list of all of your pubs, and then the latest volumes and the corrections for it. So you have your coast pilots, your light lists, your pubs by number. So you have your latest edition and the corrections. So just good to make sure you have the latest edition. And then if there's corrections that are needed, you can look those up specifically. Then we have our local notice to mariners. Excuse me. Our local notice to mariners is pretty much exactly what it says. It's specific to a local region, and they're more, I call it more temporary changes or temporary notices or I don't know, advisory things to look at. So it's always good if you're going out just to take a look at that local notice to mariners. So here's an example. A certain buoy is going to be proposing to make a buoy. I don't know. We have dredge operations going on. We have a new submerged cable at Bluff State Park. We have a buoy deployment off of Huntington Beach. We have a marine event. There's going to be a surf contest from this time to this time on this date. The race consists of, you know, stand-up paddle boarders. So it's just good to know, hey, there's going to be a lot of stand-up paddle boarders. If you want to get in contact with them, they're monitoring such and such channel, or you can call this number. So again, this kind of that temporary information. Sometimes they have pictures. This is another local notice to mariner. They're you know, painting the Vincent Thomas Bridge. So they're going to have you know, platforms set up. You're going to have a lower vertical clearance to be aware of on that. So just more detailed but temporary things that they're not completely changing on the chart. They're just I don't know, local notice to mariners. I don't know if I'm explaining that right, but okay. Let me stop that share and share my okay, this is my internet page. So if you go to your that website, that maritime safety information, and you go to the notice to mariners, these are our latest notice to mariners. But if you scroll down, you don't have to search. It can be very easy for you. So you could say, I want a range of notice to mariners and I want specific charts. So maybe I have 18,746, I don't know, 18,546. I'm just kind of making these numbers up now. 18, I don't know if they're actual charts. So you could list all of the charts that you want and then say, hey, last time I corrected charts was 2 years ago. So I'll say week 1 of 2019 to the latest one, which was 5/2021. So let's search all of those chart corrections for all of these charts for the last 2 years. And it gives me the chart number, the correction. I only have 2 for this last 2 years, and my made up charts here. So that makes it a little bit easier. You don't have to thumb through, you know, the paper notice to mariners. So using the website helps in your voyage planning. Again, on this maritime safety information website, if you go to publications, it has a list of a lot of those publications we were talking about. So you can download, here is our light lists. So if we want to download our light list for the Pacific Coast, that's going to be our volume 6 for us. If you're on the East Coast, you're going to use, I guess, volume 2. And you could download the entire light list. And again, with PDF version, you can, you know, Control F and search a certain area. Excuse me. But you can see the whole light list in a digital format. Another one I wanted to show you before we go is this is a kind of a version of a digital chart catalog. That chart catalog is kind of that big roadmap, if you will, of which charts to use when you are voyage planning. So you can use, you know, a electronic kind of chart catalog to figure out which charts you need. So, and on this one, you have the coast pilots for each area. If you're going up to Pacific Northwest, you could click on that one. I think I clicked on one for us. So your coast pilot, you can, again, have digital version of it. I think this is just chapter 1, so might have to download a few of them. But just a, I don't know, example here of most of these, you know, nav pubs do come in a digital format. But again, if you are sailing long-term and going far offshore, maybe you want a paper copy. But again, that's just personal preference for you guys. I know I'm a little bit over on our time here. The first day always goes longer than I want it to. But for next week, we're going to be going over aids to navigation as a PowerPoint, and then plotting our actual plotting, lat and long, and course and distance. So we will need nav tools. I have a little video and a handout on different nav tools and what options are out there. Let's see. Bear with me for a minute. So nav tool wise, for distance measuring, we have compass and dividers. So there's this sort of compass that just has 2 pointy ends, and then the ones that we sell at OCC has the interchangeable pencil and pointy end. And you could get them at, you know, smaller, cheaper ones at Target or Walmart or wherever, Amazon. You're welcome to use those. They just might not be as sturdy. But again, whatever you have, you can work with. Then we're going to need something to plot an angle. So we have a roll plotters, parallel rulers, and triangles as our options for there. I'm going to be demonstrating how to use all of these, so you could, you know, figure out which ones you like or which ones you don't like. Again, this is another thing that's hard with the digital Zoom learning. I usually bring all of it in, and you could use all of the nav tools and figure out which ones you want to buy. But we can't do that in this environment. Anyways, so definitely have your chart and your nav tools for next week. I will be on at 5:30. If you guys have any questions, I am always available. The homework for this week is a chart familiarization and a chart 1 kind of scavenger hunt. I don't have a video for those because I kind of put it all in the PowerPoint, and I'm recording this, and you can reference the PowerPoint as well. So check those out. If you guys have any questions with it or get stuck, feel free to contact me. That's all I got for you guys. I'm sorry I went over, but I will try to keep it to our 3 hours from now on. Let me know if you guys have any questions.